Welcome everyone to the fourth edition of All About Phage Therapy. We are honored and excited to have with us Dr. Elizabeth Betty Kutter. She's in a live discussion with us, joining us from her home in Olympia, Washington. She's lovingly referred to as the First Lady of Phage Therapy. And this phage sage is one of the most experienced, well-known, and well-respected phage scientists in the world. From having had her research cited in a Nobel Prize acceptance speech, to have founded the longest running phage conference in the world, Betty's contributions to the world of phage therapy are immense. Welcome, Betty.
Thank you so much. It's a delight to be here and to have a chance to interact again with the people there in India in particular, and more broadly than that. I had a wonderful time this last December being keynote speaker at the meeting that was held there that had a large number of people already doing phage, and particularly the first morning, about 300 students watching as well. I think I was part of at least 200 pictures during that time. But it was a wonderful place, and anything I can do to help support what you're doing there.
It was a pleasure to have you in India for the phage conference, and I think you underestimated the number of selfies. I think there were 2,000 and not 200.
Anyway, it was great fun.
Right. It was an honor and a pleasure for us to have you there, and you were the keynote speaker, of course, at the conference. And it really added such a big boost to the phage therapy movement in India to have had you there and had you share your experience.
The one time I was there before was at a big meeting in Bangalore put on by one of the main phage therapy companies, just as Ramachandran was starting to get involved. It was his retirement party, and there were hundreds of people there then too, but I was the only one that was talking about phage. And that really began to get me aware of what had happened though in that part of the world. And I was very pleased to experience the excitement of the people there in terms of thinking about phage.
Great. So you've had such a long experience in the world of phage, Betty, and I'd like to talk to you about that. You've had decades of experience in this field of phage therapy and phage research. How did you start? What was your start in this field, and how did you first learn about phages? How did you get interested in them?
Well, it's a sort of unusual story. Actually, my bachelor's degree was in mathematics from the University of Washington, and I had thought of biology as the science for people who couldn't do real science, I have to admit, and then got talked into taking a zoology class and had an absolutely amazing teacher young woman who was from Britain initially, and she talked about biology in the sense of what it was using to understand how the world worked, instead of just memorizing names or knowing a lot of different kinds of things to be able to identify. And so I decided to, instead of going on to graduate work in mathematics, even though I was at the top of the class, in fact, it was a class of 100, 3 of us were women, and I was number 1, and one of the other women was number 2 in that class. And yet, I decided the things I could do with learning something about at least molecular biology and the basics of biology would be much more interesting and much more useful. And I got married just before my senior year of college to a physicist, so we had to decide where to go together to graduate school. And we went to the University of Rochester, to the radiation and biology and biophysics department for me, to the astronomy department for him. And at first, when I got there, what they were working on was mainly using, doing various kinds of therapy with radiation. And then a few months in, we had a visitor from MIT who was working in the lab, doing his postdoc in the lab of one of the three people who later got the Nobel Prize, Salvador Luria, who later got the prize for phage for phage work, not therapy, just phage work. And the chairman of the department took me out to lunch with him. Within 2 hours, the chairman slipped quietly away, and I was absolutely enamored of phage. And John and I decided that he was going to indeed accept the position and come to the University of Rochester, and I was going to be his first graduate student. So that was how I started getting into phage. At that point, I had no idea, we had no idea that it was used therapeutically. I was working on looking at the transition from the host metabolism, the bacterial metabolism, to the bacteriophage metabolism after T4 infection of E. coli, which was an amazing thing to be part of through those years. And it was a year after my getting my PhD in 68 that Luria and two others got the Nobel Prize for work with phage. And it was he at that point that mentioned my thesis work in his Nobel Prize talk. It's something that was at that level, not related to phage therapy, but it certainly gave me strong desire to keep going. When that happened, we had just gone to the University of Virginia, and my husband had asked me to take half a year off to really full-time parent our two boys who had been born while I was in graduate school. My older son went to his first seminar when he was 10 days old, and the last one before that at -10 hours. So they've grown up with that kind of thing. But so for a while, I wasn't doing science, and then finally went to a seminar and asked questions, and people said, "Who are you? You seem to know something." And one of them, who was had done some very good work with phage before, said, "Well, I have money for a half-time postdoc for a year. Would you like to do that?" And I said, well, I had this agreement with my husband that I was going to stay at home. So he went over to the physics department and collared my husband and told him what I was doing was very important and he had to let me come and do that. Let me admit that my husband had said that I had proven to him that I actually couldn't quite keep the house the way he as a German would like it kept, so I might as well go.
And now,
Some an interesting different time in the way women were involved and were so forth with phage, with science, with research.
And now 5.5 decades later, you're still going strong with phage.
Exactly.
So what about the Evergreen State College? When did that start, and when did your association there start, and what's been the evolution of the phage work that's happened there?
Yeah, I'll start from talking about Virginia. What was happening there was that SIG had a very good position. I was just this part-time postdoc, and I he pushed me to apply after a year for a grant in my own name, and I was awarded it despite my lowly status. And then 2 years later, it was time to reapply, and I did, and this time I got. And I went to talk to the chairman about applying for a faculty position. They had several new faculty positions opened up, and he got very irate at the idea of a woman with young children having the audacity to apply for a faculty position, and said that even if I did apply, not only was I guaranteed not to get it, but he would no longer sign for my grant. So that was enough to have my husband decide to leave his position, very good position in the astronomy department there. And my parents had been sending us information about the Evergreen State College, which was just being built. That year was the first year that it was open, and we'd been fascinated by the idea of it as an experimental college with things taught and full-time programs with integrated different kinds of things like human health and behavior, or I taught in a variety of kinds of things then there later. So anyway, we decided, well, we would go ahead and apply. And the day before Thanksgiving, we were sitting on a park bench in front of the White House being interviewed by two of the deans from Evergreen who were traveling down the East Coast, choosing the next 20 members of the faculty. And we were very impressed with them, and they seemed to have been very impressed with us. And they offered, within about 2 or 3 months, we'd both gotten the offer of positions, and we never applied anywhere else.
Wow.
So that's the way it happened. So then the following fall, we went to Evergreen, and the buildings were almost finished. The science building didn't get finished till Christmas, but when I'd gone for a visit earlier, I said the only thing that made me sad was probably not to be able to do research. And I mentioned the grant, and the provost who I was talking to said, well, Evergreen wants to have as much hands-on things as possible. See if you can manage to transfer the grant here. And I did. And I was able to transfer it there. And I had money then to hire 2 of the wives of other faculty. One was a biochemist, and one was a molecular microbiologist. And they helped run my lab. Here I was starting to teach at a new school in a full-time program, in a program called Male-Female Roles in Society, and with a 5-year-old and a 7-year-old. And the lab opened then that Christmas, and it's never closed since then.
Wow.
I'm actually in a smaller lab space on the same floor just down the hall from where I was, but my original lab was really, as they were finishing building that building, they built into it a giant cold chest, the kind of thing that's, sort of a many feet across, that I could walk into as a cold room to be able to do the work in there that we needed. They put that into my lab, and it was a nice big lab, the biggest lab there. And much of the time I've been the only one to be doing basic biological research in a serious way. But it's been a wonderful place, and I've had probably thousands of students altogether through the years.
And then you soon enough started the Phage meetings at the Evergreen, right? The Evergreen Phage conferences. I think it started in 1975, if I'm not mistaken. The first.
Well, what happened was that when I was in graduate school and then at Virginia, I'd always gone to the summer Phage meetings at Cold Spring Harbor on Long Island, which was where a lot of the whole phage and molecular biology had developed. And of course, Seattle, Olympia is a long ways from Long Island. And particularly once I started having students, I did go back there once after I got to Olympia, but then in 1975, a whole group of my phage friends from different universities, there were about 15 of them that were coming out to San Francisco for a biochemistry society meeting. And I said, well, why don't you all come and visit me afterwards, and we'll have a little meeting to talk about phage. And people had a really good time at that informal one. A few people came down from the University of Washington and so forth. And 2 years later, we did it again a bit more formally. And then in 79, I went on sabbatical to UC San Francisco to Bruce Albert's lab. And the summer, that was 78, 79, I was there. And that summer, then we had a much more serious meeting at Evergreen. Took a whole group of the people backpacking for a couple of days in the Olympics afterwards. People decided Evergreen was a nice place to have meetings. And it was simply a T4 meeting from then on for many years. I didn't know about what was happening therapeutically until much later. In 1990, as we were finishing doing the sequencing of bacteriophage T4, I was working with people from Moscow and Japan and so forth. And I got a National Academy of Sciences grant with the help partly of Bruce Alberts, who went on to be head of the Academy of Sciences and whose lab I had worked with that summer before. And there, finally, with being able to do some cloning and things, it was possible to finish the sequencing. And while I was there, the people in the lab I was working with said, "Oh, while you're here, you have to go to Georgia. It's the most beautiful country in the world." So I went down to Georgia just for 3 days, visited the Eliava. It was vacation and only a couple of people were there, but I really was impressed. And I went back again one more time that summer, primarily to go climbing in the beautiful mountains of Georgia with a group from the Eliava and the Physiology Institute there. And I was hooked. So I became very excited about phage therapy. And that was when we were just finishing the sequence. And that was the biggest thing that had been sequenced until then. And the first time something like that was sequenced. And so I had a number of invitations to talk different places. And I always spent the last 3 or 4 minutes of my talks talking about Georgia and what they were doing with phage in Georgia, and managed to start going back about every second year and spending time doing things with people at the Eliava and spending time in the mountains and enjoying the good food and the friendliness.
Yeah, that's having been to Georgia and Eliava myself about 5-6 times, I can definitely vouch for that. The good food, the friendly people, and the beautiful mountains, definitely. So your association with Eliava goes back 3 decades, 1990, you mentioned.
Right.
So how has that evolved over the 3 decades? How's that association grown?
Well, when I was first there, it was a very, very hard time for them. It was a time when, the Soviet Union broke apart just at the end of 1990 when I was there. And they, for example, the Eliava no longer had the support from Russia, from the rest of the Soviet Union. It was a few of the heads of the lab that were actually seeing patients, even though they were theoreticians, they were seeing patients who might need help. The large production facility was taken over by a non-governmental group, but the basic research labs were there, and particularly Liana Gachetsilatsa and Zemfira Olivica both had become very close friends, and they came in the mid-70s both to a meeting at Evergreen. And then I realized that they had so little meeting, and the original way we set up the research foundation was in fact actually to try to have a way to help raise money to help with particularly the Eliava, and in other ways to do it. We, at that point, throughout the time until 2000 that I was at Evergreen, I managed to have small grants from the National Science Foundation. It came in about 1990. It had come into a period where there was very little available from NIH or NSF to support research with bacteriophages. They had learned how to use all of the wonderful techniques and tools that had helped to develop molecular biology, now to apply them to eukaryotic cells and human diseases even, and things like that. So I was lucky to be at a small place that had this special grants program for undergraduate institutions. And in general, we would have, relatively small amounts, maybe $75,000 a year for everything we were doing, to run the lab, and sometimes hire somebody to help. But it was a period when a lot of the people who came to the meeting were from labs in smaller schools, some big ones, but most people didn't have much money for things, and we didn't charge money for the meeting. The people paid to stay in the dorms, and we got some help from people like Bruce Alberts and so forth. But it was started as a very informal and inexpensive meeting, and we'd have our banquet would be a salmon bake in the backyard of my house, put on by members of a tribe that I had been working with out here. So it was a very simple kind of thing, but it was a fun thing. And the meeting got down to as low as about 70 people at one point. It had been probably 150 or so earlier. But then after I was in Georgia and realized that there was such a thing as intestiphage and phage, and brought those things back with me and started telling people about them and so forth, then we switched and made it a general phage meeting. Before that, we'd have a few people working with other phages. It was really, T4 was most of the development of molecular biology, and I just had happened to be in the right place and the right time, and Evergreen was a fun place to come, and very different from most of the other kinds of meetings. So our last meeting here had 350 people, though, from 52 countries. The meeting before that, it was 250 from about 35 countries or so, and only 150 the meeting before that. So suddenly it's exploding, and phage therapy is exploding.
That's great. That's excellent to hear. It's interesting that once you got to see the actual usage of phage being used therapeutically in Georgia, and that coincided with the growth that's happened at the Evergreen Phage meetings.
Oh, yeah. When it was in 1990, the second time I went in there, I got to visited there 2 years after the first. I got to go meet Goram Gvasalia, who was the chief of infectious surgery at the medical school there, and he and Zemfira Alavidze, between them, really were the absolute mistresses and masters. And I actually watched a surgery being done using phage, and it was somebody, it was a foot surgery, and he had come in to have his foot amputated, and Gvasalia had said, let me try to use phage, and he had done it. And this was, when I saw it, was the day when he was opening it up afterwards, just maybe 3 days after the surgery, and it didn't look infected anymore. That was one of the most dramatic cases that I ever saw. And then later on, there were other things too. Yeah, but Mazia, who talked to you last week, I believe, was still a graduate student then, and she was with me when I went to see that.
So over the 3 decades, you would have seen some of the early treatments being done at Eliava. Now, of course, the numbers have really gone up, as Dr. Mazia had mentioned in her session.
Well, now they do them actually at the Eliava, but at that time, it was fairly widely used by several of the surgeons, and particularly by the major department of surgical infections there. So there were large numbers of things being used. And for example, I mentioned my trip to give a talk in India in 2001. Well, on the way back from there, I stopped in Tbilisi, and I had been approached by a fellow who had read about phage therapy in a big article in the New York Times just shortly before that, and heard about it and desperately wanted to be treated. And when I was actually doing the trip, I'd met him 6 months before, and when we'd been having a meeting in Montreal, and I assumed he would have gone to Georgia and gotten it taken care of by then, but nothing had happened to get it healed, and they wanted to cut it off, and he asked me if he could meet me and go with me at that time to Tbilisi. So India had a role in that as well. And that was the first surgery that I watched, and it was absolutely amazing. And I've talked to him just a few weeks ago, and he still has his foot, and a lot was written up about that particular experience in about 2001, when they were doing a program on CBS on alternative healing methods, a major program, and they took pictures of him up here, and they came to Tbilisi and so forth. So at that point, about 2000, things were getting, there was a surge of interest, and then it was so hard to move forward that it sort of dropped off, and people couldn't get grants and things. And then it's just the last few years that it's exploded.
And I think that those years have coincided with the explosion of antibiotic resistance as well. So I think the two of course align quite closely with each other. What about the PhageBiotics Research Foundation? That's something that you founded, and it's been some time since it's been around. What was the goal behind starting that?
Well, as I mentioned, in 1997, when I had seen what was happening in Georgia, and when I wanted to try to help support Georgia, and it was founded mainly in order to try to get people interested and raise funds to support the Eliava and support extensive things going from there. So we didn't really have it supporting us until a few years after that, where we get some help, but it gradually expanded as a research foundation. But the Eliava was the primary reason for its being founded. And that was a time when a couple of the people from the Eliava were, as I said, coming over to here. At that point, I didn't use it for work at Evergreen really at all, except to help several of my students at different times go over and spend a few months each working in Georgia. And some of the Georgian students come over and work in my lab. But then it was around the time then when I formally retired around 2000 from, around 2009 from being on the faculty at Evergreen, and still was able to keep my access to my office and my lab and work with students. And I had, after that, a couple of additional 2-year grants, but over a 10-year period, I had maybe two-year grants. And in recent years, most of the money for my lab has come from some through that, and some just out of my own money. But people making donations through Evergreen, but we still keep helping the Eliava in various ways.
And
some other people too.
And in terms of the money flowing into phage research, have you seen that there is an increase in interest in that in the last few years? Have there been more inquiries?
Definitely particularly in the last few years, there's been a second explosion of interest in trying to move into doing serious work. And Amplify was the first company that got pulled together. Well, first there was a smaller company in Australia that became collaborators of ours with the people in Georgia. And then there was a company in Britain that was doing a little bit of work that had treated ear infections and had a first successful showing. And there was a company in Seattle that had been doing not phage therapy, but some other kinds of therapy. And the three of them wound up joining together and forming the company Amplify. And that was the point at which there began to be more interaction of other people with Georgia, people going there, things working out in various ways. And that was a period during which there were several people who became major donors of ours. And we were able to really help much more with what was happening over there. And one of my students went over about a decade ago now and did his PhD with the group over there that in with Rob Levine's group, and Rob Levine's group had about that time also started getting in touch with people from Georgia. And there were a couple of people there, that one in particular that now spends most of her time in that working there and back and forth, and brought a lot of the knowledge. And they managed to get the funding to be able to do a small scale clinical trial of wound kinds of things there at the Queen Astrid Hospital.
That was actually going to be my next question, because in the last few years, Belgium, in Western Europe, Belgium has taken a lead in adopting phage therapy, and there's some interesting work that's been happening last few years in Queen Astrid Hospital in Brussels. What's your opinion on that? What do you think?
Well, my opinion is it's incredible. I mean, it's not just the last few years that it started there. That's where they started doing research probably 15 or 20 years ago, and treated some patients, a few patients there. And, you know, it's taken a while to get it built up enough in Georgia, enough there generally, but they were the other strong supporters then of the people in Tbilisi as well. And it was people from Tbilisi who were helping them get going. And then the other place that there's been a hospital that's gotten involved is from Switzerland, from Zurich. And they got money a few years ago for a major clinical trial that they had planned to do on neurological problems that they had planned to do there in Switzerland, and soon decided that it made much more sense to actually conduct the trial down in a urology hospital in Georgia. But with and papers have come out recently on that, with the collaboration between the Georgians and the people there at that hospital. The other place that was involved during those years was the Pasteur Institute. And work was going on then that had started when phage were first discovered there, but really was getting built up in recent years. And the work in Tbilisi got started when Felix de Herrel, who had discovered phage, went to Georgia, became very impressed with them. After the head of what eventually became the Eliava was doing part of his training, still in his 20s, at the Pasteur Institute. So that's where the work at the Eliava starts from. And it's very interesting. We have, of course, some of the cocktails, particularly two main cocktails from the Eliava. One is called Intestiphage that has, well, we find close to 100 different phages in it. And it's something that has gradually evolved and been grown up in sort of batch wises with things added to it, not with starting from scratch ever again. So there were those kinds of things, and de Herel back in the 30s was at Yale University for a while and got some of that work started in this country. We're finding, interesting phages, that particularly the the T4 that we sequenced, that was mine that had come from New England initially, is within about 50 bases identical to the one that the T4-like phage that's in the intestiphage. You can see what's happened worldwide through some of that's going on. I know I'm going in circles a little bit, but
no, that was actually going to be my next question, because when I met you in December for the Phage conference, you had started from Seattle, gone to Japan, then come to India, then you were going to go to Berlin, then you were going to go to UK, and then you were flying back to Seattle. So you were
via
on
Iceland.
So you travel around the world and you present at so many phage conferences, you're attending so many phage meetings, and you're part of so much phage research that's happening around the world. And I wanted to know from you that which countries do you think are the best placed to adopt phage therapy? Where have you seen the maximum amount of acceptance of phage therapy? Which countries do you think are going to be taking the lead in the next 5 to 7 years when it comes to adopting phage therapy for therapeutics?
Well, I think within Europe, certainly a combination of Poland and Belgium and England and probably Holland also. There was I think a couple of physicians from Holland who went down and spent a bit of time at the Eliava and became so impressed with it that they started really using it. And there were various programs on television and so forth. And a number of the people who apply to be treated in Belgium at the Queen Astrid, and they have hundreds doing that in addition to, it was a military hospital, but it's broader. And a lot of those come from Holland. And those are some of the countries that most are sending people to Georgia now. And then often somebody will go to Georgia and be treated, but there are enough people working there who have had more back in Holland that have had some experience that they can do the follow-up and do the interactions with the people from there. Same thing is true with Belgium. Poland is more independent. That certainly has a long history and is certainly one of the major places that will be involved. Australia is another one that has really, that I mentioned earlier, that has really picked up. In South America, the place that is starting most to do it is Colombia. They've been planning actually a big phage meeting for this fall, which will probably have to be postponed due to the virus. But, and there also are groups in Argentina and in Chile doing work, moving slowly towards making things happen more. In general, the main barrier to things moving ahead as fast as they might is the fact that so many countries have, I hate to say it, American style so much requirements in terms to approve everything. You have to have extensive clinical trials and so forth, and trying to get to the point for that. And particularly since phage are a way of cutting back our medical costs incredibly, done properly. I mean, done in the ways that they can be done. Some things that have been done in this country have been very expensive because of the whole general expenses of doing it. But I have a fellow who was a student of mine in 1975, and a woman who was a student of mine in 1972, 73, who've both gotten involved in phage in various ways. My student, who is a doctor of Oriental medicine and naturopath in Portland, started doing work with phage therapy back in the mid-90s, and she talked with the people on her licensing board, and they were used to bringing in things from Asia, which were not necessarily approved in this country, but had things that were widely used and approved in their own country. And so she's used quite a lot of phage. It's a little harder to get it now, but has treated particularly gastrointestinal things and things having to do with kidney infections and fairly serious kinds of things like that. But she's treated, I'd say, several hundred patients altogether. But as a treatment and not as a study, and not doing research with it where she adds it in with other things that she's doing, particularly when some of those other things aren't working. And I think we do need to accumulate a lot of those kinds of experiences before a real study can so easily be set up. The difference between that and most of the things that undergo regular studies has to do with the fact that there are simply so many different kinds of phages and so many different bugs. And doing a study when you're putting together a very complex cocktail like intestiphage, which is sold in every drugstore in both Georgia and Russia, it's something that's sort of a universal kind of thing, but because of having 100 different phages in it against a lot of different bacteria, and to do a serious clinical trial of that according to the American standards or European standards is not likely to be very possible. So treating it as more the kind of thing that one would sell over the counter, rather than as something which is the way we usually think of as drugs. And it's been harder to convince people of that in general in this country. As I say, there are a couple of other naturopaths as well who've done a fair bit of use of phage, but so that's a problem.
That actually brings me to the next question that I wanted to ask you. And we've had a lot of people who've sent in this question as well for you. It's a question on the effectiveness of therapeutics, where you compare natural phages to genetically modified phages. What's your opinion on that? What do you think of the use of natural versus genetically modified phages?
Well, to genetically modify them, there's the question of what exactly we can and should do, what sort of modifications might be needed or might be useful. And there are times when people are picking out just 2 or 3 phages to use to treat somebody, like the person who was treated not long ago in England by a fellow who's a main phage person in this country. One of them that they used was genetically modified, and they're trying to do it to be sure there's nothing that's harmful and so forth. Well, they've been used for so long. I mean, this broad cocktail can be used, sold over the counter, can be tried by individual people, and has a good chance with many kinds of things just because it has such a marvelous mixture. And what they do with that, it's not just the mixture it was in 1930. Twice a year, they'll take the most serious infections that they've had in their hospitals and so forth, and try treating the whole, look at the results they get from treating the whole different set of them with intestiphage. And if there are particular bacteria that they find that aren't treated by that, then they're likely to isolate 2 or 3 or 4 new phages and find a relative of the problem bacteria those have hit that is not a serious problem. In other words, something that's safe to add to the cocktail that they use to grow them. And so the cocktail that you have each year, even though it has the same name of intestiphage or piophage, they're not identical. And I have ones in my lab from a number of the different years, and we're just starting to do some serious looking at some of the differences and similarities, what's happening in them, doing some sequencing work and so forth. But so I think there's use probably for both. I think for doing intravenous kind of things, you don't really want necessarily to throw in 100 different phages beyond what you're going to need. Whereas if you simply have an open wound or a gut problem that are exposed to all sorts of things anyway, it makes much more sense. So it depends on what you the ones that are genetically engineered, of course, will be able to be proprietary. People can patent them. They'll be able to be sold for a lot more money. A lot more money will have gone into making them. I wouldn't say you would want to not use either, but I think what would be the most useful are some of the individual phages. Now, staph is one of the things that, Staphylococcus is one of the things that phages are most useful for. And back already in the 1930s in this country, when there were, through the medical association, they were testing the phages that were being used in a group in the 30s, and there was another study, smaller one in the 40s. And what they said at that point is that they couldn't see that they could promisely say that it was going to work, except in the case of staph. So a number of times it was said, and that's because the phages it's a much smaller group it's much less diverse group, staph is, in terms of what it works. And it's one that's a serious problem and that's not hit by a lot of antibiotics and so forth. So, so it's going to depend. There's room for every possible way of using phage.
So you see a space for both genetically modified and the natural phages, and there would be an application for both.
So the genetically modified really only makes sense if you have a particular kind of disease problem where you have the bacteria involved normally being quite closely related, so that you can get something that can hit, and staph is one thing, except there are enough staph phages that you haven't genetically modified, but you could probably make some a little better, and at least make some that you could make some more money off of. But I would hate to see the rules made so narrow that you had to know so much about them that they can't be used in a lot of the circumstances where they're so useful. And I think that actually the intestiphage kind of thing should be treated actually more as a probiotic rather than as a medicine. In other words, a probiotic, like many of the kinds of other probiotics that are used that have a variety of kinds of bacteria, good bacteria in them, or things like that, because you're not using there something that is specifically known to be targeted exactly against what you have, and yet you're doing something where all of the phages that are put into there are ones that have been tested in various ways, so that you know, and it would be better to have it when it's all sequenced, and we have sequences of a lot of it. But in Georgia, what they were able to do was, these were individual phages that had been used on a variety of patients because they were the right thing against their thing. And then they've been added to the intestiphage cocktail through the many years. So you have a collection of the things that are best. I'd like to mention one thing I know of that is happening right now that's an intriguing difference. Amazon gets its foot in almost every doors everywhere. And there is a fellow from who's at Amazon who started about 4 years ago, when he was working there just for a year from his bacteriology lab, to come and visit our lab. We're up in that general area, and started coming back more frequently a couple of years ago, sometimes with a colleague. And now Amazon has also hired one of the people that had been one of the top people at Amplify and didn't like the way the new company took over, namely Magda, who's from Romania. And they have set up a new research program that is working to develop computer program that knows a lot about different phages, and that makes it possible to much more quickly figure out what phage cocktails will work on which diseases. And that's a completely separate little business that I know at least two of the people who are involved in it. It will probably take them a couple of years, and it'll, I don't know.
We could be looking at some Amazon branded phages in the next couple.
Some Amazon approved phages. So they've offered to sequence all of the phages that we want to have sequenced, free of charge. I debated whether, I don't know to what degree they're talking about this outside. And were this going to be broadcast purely in the United States, I might be less likely to have felt that it was okay. But I think that nobody's likely to try to compete with them on that. And I think knowing that they're doing that kind of public interest and public support kind of thing. I mean, it's primarily computer work, but every now and then, this fellow actually last year also said he was really eager to do something again. And he came in and for a couple of days assisted my students on some experiments they were doing.
Right. So Betty, we have a lot of questions which are coming in from all the people who are watching this. So I'm going to put some of those questions to you now. The first question that I'll put to you is actually from China, from a city that's in the news these days. It's from Wuhan. It's from Fasal. There are two questions that he's asking. He's saying that to treat pathogenic bacterial infections, which one is a better choice, bacteriophages or endolysins, which are the phage proteins? And also the second part of this question is that between the two, which ones are able, where is the bacteria able to develop resistance faster?
Well, the thing is that if you're talking about the phages, they can, they multiply. So you put in a small number of phages and they find the places where the bacteria are and they multiply there. And there are a lot of kinds of things that the real phages are definitely best at. On the other hand, there are some kinds of specific infections, might be an open wound infection or something like that, where you can find exactly the right phage that could do it, and you could do it either with the phage or in some cases the license work well. Again, with a license, you have something you can patent potentially, particular license, but you have to find just the right license or have just the right license for that phage. So I think as something that should become a fundamental part of our healthcare system, it should be a broad range of phages, and it should be ways of knowing a lot more than we do about each of the phages. Now suddenly people are being able to get grants to do phage work. Partly the reason we had 350 people here this year and 154 years ago is that people have been able to get grants to do the research, to be able, we charge very little for the meeting itself, but people have to travel there from all over the world and so forth, and some room and board while they're there. So it's not either or.
It's both. Both could have an application.
Both could have an application. In terms of the license, I think that there are relatively few that have enough places where they're applicable, where the bacteria causing it are similar enough to each other, even if they're the same kind, that you're going to find something that's going to work very broadly. There certainly are going to be some license that'll be good, but you have such a range of bacteria. Whereas in the phages, again, you need to find the right phages, but the fact that they can multiply, you don't have to make big quantities of them to sell. You can have a lot of different varieties, and that's what they do now at the Queen Astrid that you are asking about. They have a whole collection, and it includes, you asked about phage research at Evergreen before, and I didn't quite answer it. There have been periods when I had a lot of people there, particularly earlier in the molecular biology thing, but then also in the later years. And what we did in the last class I taught there back in 2009, it was a microbial ecology full-time program. And we had freshmen, sophomores, juniors, and seniors in the program. And I got a set of 200 cystic fibrosis Pseudomonas strains from Children's Hospital in Seattle. And we spent a couple of weeks of the labs for that program, this whole group of almost 50 students, isolated phage from different places, from sewage and from all sorts of places. And then they tested them against this parts of this group of 200 phages, strains, bacterial strains from cystic fibrosis, and they wound up choosing about, I think we have about 8 of them that are ones that they now have at the Queen Astrid, that they went ahead and did a variety of studies. And it's the sort of thing that I would love to see in India, in this country, in Europe, classes of students doing that kind of things with the safe versions of particular bacteria. The cystic fibrosis ones were stretching that in terms, we were being very careful about handling them safely, but I stopped working with those a few years later when I had a student with cystic fibrosis working in my lab. But there are things that are not so hazardous to most people, but are hazardous to people with certain problems. So does that help?
Yeah. In fact, cystic fibrosis and Pseudomonas brings me to the next question. It ties in well with the next question, which is from Atif Khan from Bombay. He is asking that what's your opinion on using bacteriophages for the secondary infections that are happening in people, especially respiratory infections, which are happening in people infected with COVID-19?
First of all, you'd have to check and see. Well, no, COVID-19 is a virus. It's not a bacterium.
Right, but
So,
saying
but
that
you're talking about secondary infections.
secondary infections, yeah, which
Bacterial
are
infections.
possibly with Pseudomonas or Klebsiella. So he's asking about
Yeah,
those.
no, I think it would be very good with those kinds of things. What you'd want to do is one of two things. Either try first with something like intestiphage or piophage, a cocktail that has a lot of different phages against strains that are related to what's happening, because the secondary infections are by no means identical.
Yeah.
So you would need to make it broadly useful. I think, though, it would be possible to put together a cocktail where you had taken a lot of the secondary infections from people. And I think that would be it would be very interesting, first of all, to try it with, Pseudomonas, I understand, is one of the bacteria that are commonly there, but there's a couple of the others that have not been used nearly as much in Georgia and Russia, and to get a hold of those and isolate phages of those and do the same kind of studies with those, I think would be a great idea.
Yeah, I think in the Indian context, Klebsiella tends to be quite a common secondary respiratory infection.
Yeah, and that's one that I know some people are isolating phages against Klebsiella. And there is some Klebsiella, I'm almost sure in both the Russian and the Georgian cocktails. We had the cocktail, there's some things in there that aren't necessarily named on the label. As I said, in Georgia and also in Russia, they'll add ones that are showing up as being very useful locally, and you'd have to have a safe Klebsiella strain to grow them in, that they would grow in.
Right. The next question is about the application of phages in dental work. So this is from Tripti Malik, who wants to know that can phage therapy be used for dental decay problems, which are caused by bacterial infections?
Yeah, well, it certainly can be used for the gum infections. To get them actually into the anaerobic part of the bacteria, where the bacteria often are, is harder. Much less has been done with anaerobic infections in general. You don't think of dental as being anaerobic, but there are, certainly some aerobic bacteria that sometimes get in around the edge, but the ones actually in the dental infections are often anaerobic. They've got a nice shell around them to keep the oxygen from getting in. And they definitely have been used in some places for that. That's one area that hasn't been developed nearly as widely as it would be interesting and fun to see. But particularly a couple of the times when I was in Georgia, I got a hold of some phage that they were using for dental things. And bone infections and that kind of thing, you have in a way somewhat the same kind of issue to do something that you can get them into where the infections are. And particularly if you're talking about in an anaerobic place, then most of in the standard cocktails, since they're grown aerobically, most of the phages involved are less likely to grow anaerobically well.
All right.
But there are incredible range of things that can be done. And I think it's exploding in the kinds of things people are going to start developing. And I wouldn't rule out any particular thing except pathogens. Don't use something that you can only grow in pathogenic strains. You need to find something where you have a definitely non-pathogenic strains that you can grow it in.
The next question is from Meera, and she's asking that what are the positive steps that can be taken to encourage countries to start adopting phage therapy for therapeutics, especially with the growing problem of antibiotic resistance?
I think it's happening. and I think there are many countries that are starting to do it, and at varying levels. On my way home from the meeting in India, I'd heard just a few weeks before about this gathering in Berlin that you mentioned that I went to. And there were, it was at the military hospital there, and they were interested in everybody's experience in trying to use phage for wound infections. And a number of the people who were there were actually going ahead and, in a limited scope, for individual physician, individual patient, making use of it. And I think that it's important to be able to go ahead and study things and do things with phages that are known to be safe and grown in bacteria that are known to be safe. And then have a whole collection like they do that they're building up at the Queen Astrid and some other places where, and the other thing that's been happening that made possible the saving that fellow's life that's brought so much more interest to this country that happened 3 years ago in San Diego, have people have access to have phages that they're doing tested in a central way, and do it with places where people can ask when they have particularly serious problems, and particularly if you have something like a refugee camp that has an epidemic of something, or some kind of thing that's going around where there are a lot of the same kind of bacteria, to figure out ways to do that.
So having a phage library which is readily accessible would be an important step.
And there are two ways of having a phage library, and one of them is having an individual phage library that's quite different at each institution, and to a certain degree that's useful to be able to have. But the other thing would be to have a central major phage library that's phages that have been found to be useful in a number of places and ways, and have that be, I would say, something that's available in a nonprofit fashion, so that one could easily, if one has bacteria, in the US, the Navy were the ones that had been building up a big enough library of pathogenic bacteria, mainly both the Army and the Navy, mainly coming back from Iraq and all, and phages against them. And choosing the right phages can be hard, but there are techniques being worked out to do it rapidly. And I think that's why Amazon is getting interested in figuring out the ways to help people to be able, as quickly as possible, to identify what might work as quickly as possible.
So
and if they do that properly, rather than having a few private companies mainly doing it, then you could wind up getting something where it was a kind of research to have undergraduate research in 100 universities across the country, gathering different phages against the particular kinds of bacteria and testing them, and the ones that look broadly useful have a central place to send them in that is some sort of nonprofit kind of thing that could cover its expenses. And then there'll be companies that can isolate very specific ones for very rich patients and so forth, but then it would wind up being able to help people in the poorest parts of the world, as well as everyday kinds of things, as well as some ways for companies to make lots of money.
So the next question is from someone who was a part of the Phage conference that you attended in India in December. Her name is Suvarna Ramamurthy, and she's asking that what was your experience with the Phage conference in India in December, and what was your biggest takeaway from the conference?
My biggest takeaway was, first of all, was that I gained incredible enthusiasm seeing how they were moving forward, and the number of people that were doing things, with the vastness of what's available, and also meeting you guys. I mean, as you know, I just turned 80, and when I got back, I wound up with some, or I knew actually that I had some health problems I was going to have to deal with. It gave me a great deal of excitement, enthusiasm, because in India is a place where developing something where it can be made available in broad ways to the people with the least money, and yet where you also have the kinds of places that can probably afford to sort out and produce some of the more expensive things. India is wonderful. And people were so enthusiastic, and I felt so welcome. You know, I mean, you clearly respect elders there. And as I said at the beginning, the fact that I had at least 200 selfies taken during a period of 3 days can say something to what I was feeling.
Add another 0 to that, not 200, but probably 2000. All right, so the next question is from Maria Jones, and she's asking about intravenous phages. So she's saying that are they more effective, as well as are they more dangerous in using as compared to oral or topical administration of phages?
Well, I mean, excuse me, just a sec. I don't think you can make it a general statement like that. You clearly need to have them more thoroughly purified if you're talking about intravenous. You know, if you're talking about orally, you know, we take in small amounts of pathogenic bacteria all the time in food we eat and water we drink and things like that, and our body has ways of handling them. If you're talking, and I think you can bear that in mind, I mean, you want to use hosts also for the oral bacteria that you know are not major serious pathogens, but they may well be things that might make somebody sick. And they might be things that might stimulate the immune system in a bad way, for example, or whatever. But I think that the way they've been doing it in Georgia, of having this maximally complex kind of thing, and it's interesting that as far as I've been able to figure out, they have never started intestiphage again from scratch from the early days when it was developed with the phages that were coming already from Paris and so forth. They just have continually allowed it to modify, and right. Things that aren't growing well against the bacteria that they're using to make them, you'll gradually get somewhat different hosts, and as you get different hosts, you'll get overlapping but distinct kinds of things there, and you can easily keep, or fairly easily keep, as they do each year, improving what they are doing for that period of time. You can't do that intravenously. You can't put in those kinds of crude lysates and so forth intravenously. At least that's my perception. Right. You know, you need to do a fair bit of purification.
The next question is from Iraq, actually, and his name is Saad Al-Musawi. He's asking that he's obviously a phage researcher, because he's saying that if I isolate a phage with lytic capacity towards a specific host bacterial isolate, does this mean that the phage is virulent even with lysogenic tendencies?
Just a second. No, it doesn't. I mean, if it has lysogenic tendencies, you probably won't want to use it. And read what he said exactly again.
He's saying that if I isolate a phage with lytic capacity towards a specific host bacteria, does that mean that this would also have lysogenic tendencies towards that bacterial isolate?
Not automatically. Lysogen, let's call them temperate phages, that can be there without lysing, will also be lytic towards some hosts. I mean, Martha Clokey has done a lot of work with E. coli 0157, and it's very hard to find phages that will work against some of these things. But what if you take some of these severe pathogens and get a phage that can lyse it, it may or may not be that it can, in some strains, be temperate. But in other words, survive along with the bacteria. Being temperate just means that it's going to be able to be for a year or 10 years or 1,000 years still inside the progeny of that bacteria as you go along. And there will be probably some phages that have that property that will be useful for some forms of phage therapy. But I would say that's much more dangerous. I mean, it needs much more oversight, much more following exactly of the patient. That would not be the thing that you would sell on the local pharmacy.
Right.
Does that make sense?
Yeah, that wouldn't have therapeutic applications.
Yeah, I mean, even that, you might find a particular patient where that was the only phage that would hit the bacteria that they were sick with. And you might be able, or that you have to do something intravenously, that you would be very careful with what you did, and there would be more chance of there being a problem, and you wouldn't want it to be part of a big mix of phages.
Right.
Does that make sense?
Yeah, I think that answers the question. And I think you need a hot cup of tea, Betty. So I just realized we've had you on for more than 1 hour, 15 minutes. And it's been an absolute pleasure to have had this discussion with you about phages. We are continuing to get some questions. So what I'm going to do is I'm going to send these over email to you, and then you can answer them one by one, and then we can have those answers go out to those people. It's been a wonderful honor and a pleasure for us to have had this discussion on phages with you. And thank you so much for taking out time for this.
Oh, it's great fun for me. And sorry that I'm having some coughing problems, but I'm perfectly willing to go on a few more minutes, though. I think I've gotten it caught again, if you want to.
Okay, all right. In that case, I'll put 1 or 2 more questions to you. There's a question from Suzanne, who's actually taken treatment at the Eliava clinic. And she's asking that can phages with higher titer count be used for topical infections like skin infections?
Yes. With high, I mean, in general, if you were doing something like a skin infection where you're not having them be in a liquid where they can multiply easily and so forth, you might well want to have a somewhat higher concentration. It depends on what your concentration of bacteria and so forth are. If you have a place where they can do a lot of multiplying without getting killed or removed, then, I think that most of the phages in testifage had a concentration of somewhere around 10 to the 5th or 10 to the 6th per milliliter. When people are testing things, sometimes they add them at a higher concentration, or if it's in an open thing and they can multiply there, if you start by adding 1,000 phages and they have nothing that's killing them, they can accumulate enough. And you also need to pay attention to how well they survive, what kinds of media they're in. I just got a paper from a student I've been working with who's in Thailand, and she isolated, did some more isolating some phages, and what she found was that there were, she tested the different phages that she had then as to how well they kept their titer over a period of time. And she found the two best phages that she found, one of which is closely related to one of our main phages, lasted very well. She, after a full month in the standard medium, it had dropped only about 2%. And another one that was more lambda-like in the same medium was okay for 2 weeks, and then it rather suddenly dropped by orders of magnitude. So, you know, if you're trying to use them to put together a cocktail or whatever, you need to think about what media they're in, what other things go in with you're growing up the other phages that you're going to have in there, because you're not going to have pure phage with no liquid around or no anything.
Right.
So it's worth it to see what works under the conditions you have. One of the things, by the way, that I mentioned to you that we did a significant amount of work with a couple of decades ago, and now we're going to go back and publish more of it and do more of it, is to look at phage infection anaerobically. You know, most phage studies of knowing what they'll hit are done aerobically. So that's worthwhile.
Okay.
Thank you.
All right. So, Betty, I think we should wrap it up now. As I said.
Sorry.
No, I think you need a hot tea now. So once again, thank you for being here. Thank you for answering all of these questions, and thank you for sharing your experience, your knowledge, your perspectives, your insights. It's been a pleasure to have you here, and just the number of questions.
If you reach a point where you decide you'd like to have me come back again in 6 months or so, sure. I would be more than glad. I love to meet with people and talk with people and talk about phage.
That'll be wonderful. And I think the number of questions that we are getting is a pointer to how much people want to hear from you. So we'll definitely plan that and have you back again. And I'd just like to thank everyone who's tuned in, and thank you for your questions, your comments, your participation. And we'll be back soon with another live phage therapy discussion. So stay tuned for information on that. And thank you and goodbye.